Alright, in this video we're going to talk about Unit 5, Objective 2, finding out or limits algebraically. So we're going to start with the limit as x approaches 0 of sine of x. So if we think about what we did in the last video, we would look at the graph. We would take a look at the graph and see what the function is approaching as we get closer and closer to that x value. So if we look at the limit from the left-hand side, so what our function is getting closer and closer to the left, we would see that it's getting closer and closer, our function is getting closer and closer to 0. As we come in from the right, our function is getting closer and closer to 0, so we would say that this limit is equal to 0. Now, if you don't have the graph, we can do this algebraically. So if we think about what's going on at that point here, we can look at it and say, well, all I have to do is plug in that x value and evaluate, and that's what's going to be what the limit is approaching, right? So if I have the sine of 0, we know the sine of 0 is 0, so our limit of sine of x as x goes to 0 is going to be 0. Now this should make sense because as you're plugging in y values closer and closer in from the left and closer in from the right, we're getting closer to plugging in this y value, and what's going to be more accurate than actually plugging in that y value. So our limit here is going to be 0. Now this is going to be useful not very often. AP is not usually going to give you a question where you can just plug in the number and get an answer out. What's more than likely going to happen is you are going to get something called an indeterminate form. And indeterminate forms look like stuff like 0 over 0, infinity over infinity, infinity over 0, 0 over infinity, and any of those infinities could be negatives. And we're going to call those indeterminate forms. And we call them indeterminate forms because we don't really know what they equal. Is 0 over 0 1 because we're dividing something by itself? Is it 0 because 0 divided by anything is 0? Or is it undefined because anything divided by 0 is undefined? We aren't really sure. We get what's called an indeterminate form. So how we are going to attack indeterminate forms is we have two things. The first thing we can do is factor, and I'll say slash simplify. Then take the limit again. Because anytime we see one of these indeterminate forms, it's telling us that the limit is actually going to exist. So indeterminate form, if you get something like 0 over 0, we have an answer, we just don't know what it is. So we're either going to have to factor and simplify and then take the limit again, or use what's called L'Hopital's rule. And L'Hopital's rule just says take the derivative of the top and of the bottom. So take the derivative of the top and bottom, then take the limit again. So we'll look at an example where we'll use both of these, and then we'll call this video, we'll call quits on this video. So let's look at the problem. The limit as x approaches negative 1 of x squared plus 3x plus 2 over x plus 1. So we need to think about this algebraically first. We want to plug in negative 1 to our limit, right? As x approaches negative 1, we're going to turn all of our x's into negative 1 and see what happens. So we'd get negative 1 squared plus 3 times negative 1 plus 2 over negative 1 plus 1. So we're going to end up at 3 minus 3 over 1 minus 1, which is 0 over 0. So we have an indeterminate form. 0 over 0 doesn't mean our limit does not exist. it means that our limit does exist. We just have to manipulate what we have in order to make it able to find the limit. So our first way we could do it algebraically is factor and simplify. So the top is going to factor into x plus 1, x plus 2, and our denominator is just x plus 1. So we can now cancel out our x plus 1 factors. So now we're just looking at the limit as x approaches negative 1 of x plus 2. And if we go back to what we just did a second ago, take our limit, we're just going to plug in that value, and we're going to get the limit is equal to 1. So that's the first way, is we can factor and we can cancel. Or we can use L'Hopital's rule. So L'Hopital's rule says once we get here, or any other indeterminate form, what we want to do is take the derivative of your numerator, take the derivative of your denominator, and then take your limit one more time. So the derivative of your numerator is 2x plus 3. The derivative of your denominator is 1. So we've taken our derivative. So now all we have to do is plug in our negative 1 value. So 2 times negative 1 plus 3 divided by 1 is going to give us that same value of 1. So either way you want to do it is going to be okay. The big thing that we need to look out for, that we need to make sure happens, is we get some sort of indeterminate form. If you get something like this as your answer when you plug in a value, so let's say if we get the limit as x approaches 1 of x plus 3 over x minus 1. When you go to plug in your value of 1, you're going to get 4 over 0. That is not an indeterminate form. That is just undefined. Right? We know for a fact that 4 divided by 0 does not exist. There's nothing indeterminate about it. It's only indeterminate if you have something like 0 over 0. So 4 over 0, or likewise 0 over 4, would give us an answer. The answer might be does not exist, but it will give us an answer. We don't have to do any more work. So we'll call it quits on that video. See you on the next one.